Yes, Adil, we are starting aldehyde, ketones, and carboxylic acid today. If you guys have any doubt from the last chapter, coordination compounds, please let me know now. We can discuss them and then we can start aldehyde ketones. Okay, so please write the chapter. Write the chapter's name, aldehyde. Ketones and carboxylic acid. Now, simple introduction. What are these things? So aldehyde, you can look, you'll see something like this, CHO, or this is aldehyde. Then for ketone, if you have carbon double bond O, and there are some carbon attached to this carbonyl carbon. Okay, so this carbon C double bond O is known as carbonyl carbon, and if you have some different groups attached, then it is known as ketone. Or it can be written as RCO and one more dash. This is ketone. In this chapter, we'll also learn about carboxylic acid, double bond O, OH, or you can have something like this. Or you can have RCOH. Then you can also find esters here, C double bond O, and this next oxygen atom, single bonded to carbon, it is connected to an alkane. Some alkyl group R. You can have this as this is ester. Then you can also find anhydrides, C double bond O, O, C double bond O. And then you can have here another carbon group like this. Okay. Right, next, some common names. No. In nomenclature, first of all, write some common names that you have to remember. First one is, see, if you have this fragment, CH3, C double bond O, then this will start with ACE, okay? If you add an OH here, so this will be acetic acid, okay? Similarly, if you have CH3, C double bond O, if you add a hydrogen here, this will become acid aldehyde. Similarly, if you have CH3, C double bond O, you add a CH3 here, this becomes acetone. Okay, so in all of these, what is the common fragment here? This is the common fragment. Okay, and all of these, they contain this acid, acid, acid. If you add OH to CH3 C double bond O, it becomes acetic acid. If you add a hydrogen, that becomes acid aldehyde. If you add a CH3, it becomes acetone. Similarly, you have another which is known as form. So if you have HC double bond O, if you add a OH here, this becomes formic acid. Again, if you have H C double bond O and you add a hydrogen here, this becomes formaldehyde. Okay, so both of these are very important. Please remember these things. Okay, acetic acid, acetaldehyde, acetone, formic acid, and formaldehyde. You have to remember it as they are the IUPAC name, even though they are common names. But you will never see someone writing this as propane 2-one. They will always write it as acetone. Okay. Similarly, this one, no one is going to write this as ethanoic acid. In all the textbook, most of the times they refer this compound as acetic acid. Similarly, this one is not methanoic. This is a methanoic acid, but you are not going to refer it as methanoic acid. You are going to call this formic acid. Similarly, this is formaldehyde and it is not methanaldehyde. Okay, so please remember these common names. These are used as if these are the IUPAC names only. Okay, so please remember these names. Then there are some more. Please write, which are not very important, but it should be there in your notebook. So once you're revising, you go through them. If you have 3 carbon atoms and COH, CH3, CH2, COOH, so this is known as propionic acid. If you have CH3, CH2, CHO, then this is known as propion aldehyde. Similarly, if you have 4, you have 4 carbon atoms, this is known as butyric acid. This is butyraldehyde. Done everyone? Yes or no, please tell me. Done everyone? Is there anyone who's still writing? Please let me know. Now please write use of please try to speak up. Alpha, beta, and gamma. for position of substituents. No. What is alpha carbon? Carbon directly connected to the functional group. What is beta carbon? Carbon directly connected to alpha carbon. What is gamma? Carbon directly connected to beta carbon. See, first of all, how you have to do. Okay. बात बहुत सारे बच्चे ना सुनते नहीं है बात को. Please ध्यान दीजिएगा कैसे करना है. I want the answer, each and every answer correct. I'm not going to explain it once again. Okay, this is very simple thing. Listen it very carefully. I will be giving examples for both aldehyde and carboxylic acid. In both of these cases only we use alpha, beta, and gamma. So what is the functional group? First of all, identify the functional group. So this is the functional group. Because if you want to identify alpha, we need to identify the functional group. Now this carbon, this is the functional group, and this carbon atom is attached directly to the functional group. So this is my alpha. Now this is connected to this one directly. This is my beta. And now I have two gamma carbons. Both of these carbons are gamma carbons. Similarly, if you have something like this, then in this case, this is the functional group. Now this is the alpha carbon. Now both of these are beta carbons. And this is gamma carbon. Now write the other questions. Please send your answers on WhatsApp. Your answers are right, but please correct the structure. आपने इसको बहुत अजीब तरीके से बनाया. You have drawn it like this. It suggests that there is a carbon atom here also. Okay. So please draw it correctly. Like this. Otherwise, your answers are correct. Very good. Ahmad, your answer is wrong. First answer is wrong. Second is correct. First answer A. Okay. C. Yeah, correct. No, correct. Your answers are right. Very good. Abdurrahman, looking at your answers now. Oh, this is not gamma. This is not gamma, Abdurrahman. Gamma should be directly connected to beta. Okay, so it is not directly connected to beta. Please correct that. B alpha is correct. Beta, gamma, gamma, correct. Alpha, beta, gamma, correct. Jiva, looking at your answers. Alpha, oh, beta is wrong. Sorry?
So for me, C is not correct.
C.
Yeah, it's not correct.
Yeah. C is not correct. One of the gamma will not be there. There is only two gamma. There will be only two gammas, not three gamma. Jiva, first answer, it's not right. Alpha is right. The two betas that you have drawn, that you have identified, that is wrong. Then in the D case, alpha, beta. No, you got confused there. Okay. Please look here, guys. आप लोगों ने आधे केसेस में फंक्शनल ग्रुप आइडेंटिफाई नहीं किया. That is why you guys get wrong. अगर आप लोग फंक्शनल ग्रुप आइडेंटिफाई किया करते हैं. This is the functional group. And this is directly connected to this carbon atom. So this is alpha. Alpha is directly connected to beta. This is also beta. And beta is directly connected to gamma. Beta is directly connected to this gamma. That's it. Okay, you don't have to go there. This is going to be delta, but again, you don't need to know about delta. Now here you have, this is the functional group. Directly connected to alpha. Now alpha is directly connected to beta. So this is also beta. Now beta is connected to 2, 1 gamma and 2 gamma. Here, this is my aldehyde. Functional group directly connected to alpha. Now this alpha is directly connected to beta. Beta is directly connected to gamma. And there is again one alpha connected to beta. Okay. Huzaifa, your E case is wrong. I hope you can see that. Why E is wrong. Now, please see, we can also name it using alpha, beta, and gamma. But how are we going to name this? So, see the first case. In this first case, I'm going to switch the background. It will be quite bright now. Okay. Now, please see. This is going to be my main chain with 4 carbon atoms, and I have a methyl group at which position? This is alpha and this is beta position, right? So what is this? This is beta methyl butyraldehyde. Or we can also write this as beta methyl butanol. Now, what about this one? One, two, three, four carbon atoms, and alpha is having a methyl group. So this will be named as alpha methyl. One, two, three, four. Butanoic acid. Okay, or what else you can name? You can name this as alpha methyl. Butyric acid. Both of the names are possible. Here you can't, I mean, there is no alpha beta used here because it is just cyclohexanone. Since this does not have any substituent, so you don't need to worry about this one. But let us look at this case. Now, in this case, we have one methyl at alpha, one methyl at beta. So it will be alpha, comma beta, dimethyl, butyric acid, or alpha, comma beta. This is just a comma, okay? Dimethyl butanoic acid. Here it is going to be alpha carbon having a methyl group here. And in total, we have 1, 2, 3, 4 carbon atoms. So this is going to be beta methyl butyraldehyde. Okay. So main thing is that you don't have to write the names in such way. आप लोगों को इस तरह से लिखने नहीं बोलेगा. अगर आपको किसी ने ये कंपाउंड दिया तो आप यहाँ पे लिख सकते हैं 1, 2 methyl butanol. But दिक्कत तब आती है जब आपके पास ये कंपाउंड ऐसे लिखा हुआ है and it says that you have to draw the structure of beta methyl butyraldehyde. Now in that case you should know what it is saying. Wait a second, this is going to be alpha methyl, not beta methyl. My bad. Because alpha carbon is having a methyl group, not the beta carbon. Okay. So please write this down. Write this down quickly, guys. Shall you write next? Common names of ketone using the alkyl substituent. Okay, so for example, you can have something like this. CS3, CS3. So how we can name this using the alkyl group? What are the alkyl groups attached to the ketone? You have this one CS3, one CS3. So this is dimethyl ketone. Dimethyl ketone. Then if you have something like this, now this is ethyl, this is methyl. So ethyl mein E comes first, so this will be ethyl methyl ketone. Okay, so ketone अब स्ट्रक्चर कैसे बनाइएगा? कीटोन के लिए सबसे पहले बना दीजिए C डबल बॉन्ड O. Then ethyl के लिए 1 and 2 carbons. Ethyl के लिए 1 carbon. That's it. This is your ethyl methyl ketone. Right, next. Now there is another structure which is very important for you to remember. Now again, we have got CH3 and carbon. So that means this is going to start with acid. And then we have this benzene ring. So acid. Then you have the phene, PH. And ON for the carbonyl carbon. Okay, so whenever you have CH3, C double bond O, so obviously it is going to be what? Acid. Right? Then you have the phenyl group. So it is acid phenol. Acetophenol. It is acetophenol. If you have benzene ring, C double bond O, and then again a benzene ring. So this is known as benzophenol. All of these names you should be knowing, okay? If you have been given this name, you should know what is the structure also. Because in the questions they will be using when acetophenol is reacted with, when the dimethyl ketone is reacted with, when ethyl methyl ketone is reacted with. So in such type of question, you should know what is the structure of the reactant. Right, next. Now I will not be discussing IUPAC nomenclature because I have already discussed this in haloalkane halorine chapter. In that I have done all the complete IUPAC nomenclature. Okay, so if anyone has any difficulty, then please refer to those lectures. And if still you cannot write the IUPAC names for a structure, please message me. There is rather one structure that I want to tell you guys. It is the structure. If you have something like this, then it should be named as this is the functional group here. Now this functional group is carbaldehyde, and it has a substituent that is cyclopentane. This will be cyclopentane carbaldehyde, or you can also write this as cyclopentyl carbaldehyde. Also, please see if you have CHO, CHO, and CHO, then please number it 1, 2, and 3. So this is going to be, this is tricarbaldehyde, 1, 2, 3 tricarbaldehyde, and then again we have the cyclopentyl group. Okay, so please write the name. So कैसे लिखिएगा? You have how many carbaldehyde? You have 3 carbaldehydes. So you can write it like this: cyclopentyl 1, 2, 3 tricarbaldehyde. Okay, this is important. ये आप NCERT में सवाल है, शायद आप लोग से कभी ना बने. After this, you are going to write the topic. Method of preparation of aldehydes and ketones. No. In method of preparation of aldehyde, there are 3 different, there are 3 different sections. First of all, we are going to look at those method of preparation, which is going to give you both aldehyde and ketones. Okay, so you're going to have both aldehydes and ketones. So please write the method of preparation, that is A part. Method of preparation for both aldehydes and ketones. In this, write number 1 from alcohols. Now we can prepare aldehyde and ketones from alcohols by what reaction? Tell me, guys. We have done already this in alcohol, phenols, and ethers. Alcohol, phenols, ethers. If you remember, we have done these type of reaction in which we started with alcohol and we got aldehyde and ketones. What were those reactions? Try to remember. What was the reagent? Try to remember that. Flip some pages, you may get something. Look at your notes, you will get something in alcohol, phenols, and ether. In the chemical properties of alcohol, phenols, and ethers, we saw that when we reacted alcohols with different types of alcohols with something, we got aldehyde and ketones. Nothing. है ना, कुछ रिवाइज वाइज कर नहीं रहे हैं आप लोग तो कहाँ से याद रहेगा? प्लीज राइट बाय ऑक्सीडेशन. Again, the same reactions are here, okay, as in alcohol, phenols, and ethers. So if you react 1 degree alcohol with PCC, then we are going to get aldehyde. If you react 2 degree alcohol with PCC or any oxidizing agent, CrO3 or something else like that, then you are going to get ketone. Okay, so for example, if you have 1 degree aldehyde, this is going to get converted to okay. So whenever you have to do the transformation that they ask you, what is the reagent that is going to be used, always write PCC. Okay, always write PCC, but also remember there are other reagents that can be used, such as CrO3 in the case of ketone. But in the case of aldehyde, please remember just PCC, nothing else. Okay. Also, like if you are going to use PCC, that is not going to disturb your double bonds. So that is also very important. If you have something like this, whenever you see a double bond and alcohol and they're asking you to oxidize it or to get a ketone from here, for example, they are asking what is the reagent A. So in this case, what is happening? The double bond is not disturbed, but the alcohol is getting converted to ketone. So this A is going to be PCC. Yeah. To get carboxylic acid, we use strong oxidizing agent with 1 degree alcohol. But since we are not doing a carboxylic acid, we don't need to write that now. Write this quickly. And again, for this ketone, what are the oxidizing agent we can use? Please see. For this ketone only, okay? You can use Na2Cr2O7 in the presence of some acid and water. Okay. Then again, we are using PCC. Obviously, you can use PCC, and then you can also use CrO3. But this should be not in water. This should be in acetone. Okay, so for ketone, you can even use strong oxidizing agent, but please don't heat it up if you're having strong oxidizing agent. Otherwise, it is going to give you CC bond cleavage, and then it is going to give you different types of carboxylic acid. In ketone, you can use strong oxidizing agents such as Na2Cr2O7, but please don't use heat in this case for 2-degree alcohol. Again, हमेशा के लिए what I would suggest is to remember only one, that is PCC. Okay, remember only one, that is PCC. Right, next, catalytic dehydration. Catalytic dehydrogenation, not dehydration. Please write next one. B part. Catalytic dehydrogenation. Now, for this, we know that 1-degree alcohol. Wait a second. Let's write an example also. If you have R, CH2OH, this is 1-degree alcohol. It will give you RCHO. What we have to use? We have to use copper at 573 Kelvin. If you have 2-degree alcohol, copper 573 Kelvin. This gives you ketone. Write a note. Degree alcohol gives alkene on treatment with hot copper. Due to absence of alpha hydrogen. Right, the next point in note. अच्छा, इसमें आप लोग देख लीजिए, अल्कोहल चैप्टर से भूल गए हमने. So if you have CH3 and CH3. Now in the presence of hot copper, what is going to happen? Here dehydration happens. So this OH is being removed and one hydrogen from the carbon atom. So you get CH3. From this carbon, you have removed oxygen. Sorry, the hydroxyl group OH, and from the above carbon, you have removed one hydrogen, CH. This will be CH2 bonded to CH3 plus water. So we get an alkene when we have 3-degree alcohol. At another point, Ag can also be used instead of copper. Right, next. From hydrocarbons. From hydrocarbons. From hydrocarbons. Okay. Right, the first reaction by hydration of alkynes. By hydration of alkynes. Please look at the reaction first. We have R and C triple bond C. And then again we have R. When you're going to add water into it, you're going to have hydrogen and then OH. So one of these carbon atom is going to get hydrogen, the other carbon is going to get OH. So what is the product that we are going to get? Whenever you are going to add anything on a double bond, one of the pi bond is going to break. So in the reagent, you are going to write H2O, dilute H2SO4, and HgSO4. Now R, C, double bond C, okay? And then you have OH. Let me get some space. Here you have OH, and here you have hydrogen. And then the other R. Okay, now please see. This hydrogen is going to be delta positive because it is connected to oxygen atom. Okay, this is connected to oxygen atom. And this pi bond is having electron density like this. This is the internuclear axis, and this is having above and below, there are some electron density. Now, this electron density is going to give the electron density to the hydrogen, and this bond breaks, and if it gives you a double bond like this. So what you are going to get, this is a kind of intermediate that we get. And after that, we get R, C double bond O. Then this carbon gets another hydrogen, CH2 and R. Okay, so this is known as the enol form. Okay, so this is an enol. What is enol? This carbon atom, it is having a hydroxy group and also a double bond. So whenever a single carbon, the same carbon has a hydroxy group and a double bond, that is known as the enol form, and it automatically rearranges to the keto form, that is like this. Okay, so if you have something like this, please see. So first of all, write the statement for this reaction. Aldehydes and ketones can be prepared by hydration of alkynes. Hydration means adding of water. Hydration of alkynes in the presence of dilute H2SO4 and HgSO4. What happens first? Please write water adds to alkyne forming unstable enol which rearranges to form aldehyde or ketone. Right, next point. Addition of water occurs via Markovnikov's rule. अच्छे से समझ लीजिए रिएक्शन को, then I'm going to give you multiple questions here, okay? I hope all of you remember Markovnikov's rule. नहीं तो पेज पलटिए, halolken halorine. In that we have done addition of HBr. Okay, to addition of HBr into alkene. Please look at that Markovnikov's rule. Okay. Find wherever your Markovnikov's rule is there in your notebook. And if you can't find it, shame on you. You don't know your notebook. You should be knowing your notebook now, which chapter is where, which topic is where. Okay. That is going to help in the exam. That is why find the Markovnikov's rule, flip some pages in your notebook and find the Markovnikov's rule. Read it once. If you remember it, then it's fine. Then it's good if you remember it. So I hope everyone is done writing this. Now please see the first example. Please see the first example. Now, please don't write, leave your pen aside and listen here. I'm going to add water to this. Dilute H2SO4 and HgSO4. So, oops, sorry, this is going to be water, not H plus. Now, both of these carbons are same. Please listen to me when I'm saying these things. Both of these carbons are same. That is why any of the carbon can get hydrogen and any of the carbon can get OH. So, carbon, let's suppose the first carbon gets the OH. Then this becomes double bond from triple bond because we have done addition, and this carbon gets the two hydrogens. It gets the hydrogen now. Now what is going to happen? Rearrangement. Pi bond from electron source, electron rich to electron poor. And then this is going to leave the bond to C double bond O, giving you H, C double bond O, single bond, CH3. It already had two hydrogens. Now this carbon atom is going to get the third hydrogen also. Please write this down and look at the next one. अच्छा एक बार रुक जाइए, इसको देख लीजिए. CH3, C triple bond, CH. Now here also we are going to have H2O, dilute H2SO4 and HgSO4. Now in the first case, again, we have two different carbon atoms here. Please listen now very carefully. The red carbon atom and the green carbon atom. Now tell me, to which carbon atom will OH attach? OH will attach to red carbon atom or the green carbon atom? Please write the answer in chat. OH will attach to red carbon atom or the green carbon atom? OH will attach to the red carbon atom or the green carbon atom? I've got only two answers. OH will attach to which carbon atom, red or green? OH will attach to which carbon atom, red or green? Okay. Now, I hope all of you are answering from Markovnikov's rule. How many of you read the Markovnikov rule? Please tell me. Zan, turn your mic on and read the Markovnikov's rule.
सर मैं रीड नहीं पर बोल सकता हूँ आंसर क्या है?
हाँ बोलिए बोलिए.
हाँ, तो reaction with HBr, it goes to the carbon which has the least number of hydrogen atom, ना?
What goes to what?
As a water example, water will go to the carbon which has the least number of hydrogen atom, right?
Water. हम तो पूछ रहे
In
OH
this-
किस पे अटैच होगा ना? OH किस पे अटैच होगा बताइए.
green में
लीस्ट नंबर ऑफ हाइड्रोजन किसके पास है?
ये green में है ना, खाली एक ही H है, red में 3 है.
रेड में 3 है. फिर से देखिए.
हाँ सर,
Keep your
red
mic.
है, red. जी सर, red है,
क्या
red
है?
red है, red
आप लोग
है
को ये
सर.
नहीं दिख रहा है कि हाइड्रोजन किस में ज्यादा है और किस में कम है ना? मार्कोनिकॉफ रूल जानते हुए भी गलती कर रहे हैं. रेड कार्बन एटम इट हैज 0 हाइड्रोजन. सो द रूल सेज दैट नेगेटिव पार्ट, जो भी आपके पास अनसिमेट्रिकल रिएजेंट है उसका नेगेटिव पार्ट अटैचेस टू कार्बन विथ लेस हाइड्रोजन. ऐसे कैसे चलेगा काम जैन? Okay, so which is having less hydrogen? The red one is having less hydrogen. Now, the first thing that you have to do is to identify the carbon atom that is having least number of hydrogen whenever you are doing hydration of alkynes. Now, also one more thing is that you have to point out whether both of these carbon atoms are same or different. In this case, both of these carbon atoms are different, so you have to mark them and then attach the OH. So you will write CH3. CH3. Now this C triple bond will become C double bond. Now this carbon gets OH. This carbon atom gets the hydrogen. Now again, this double bond attacks here. This OH gives the electrons to the carbon atom and the oxygen, making CH3, C double bond O, CH3. ठीक है? तो ये कार्बन क्या बोलता है? तुम मुझे हाइड्रोजन दो, मैं तुम्हें बॉन्ड दूंगा. ठीक है? So it gives this oxygen atom gives carbon hydrogen and oxygen atom gets double bond. Right, next, if you have CH3, C triple bond C, and again a CH3. Now in this case, बताइए symmetrical alkyne or asymmetrical alkyne? Is this symmetrical or asymmetrical? Tell me guys, symmetrical or asymmetrical? दोनों carbon atoms on the double bond, I'm sorry, on the triple bond is same or different?
Same.
Yes, correct. जिन लोगों के आंसर्स नहीं निकल रहे ना, वो लोग पूछे हमसे सर क्यों सेम है, नहीं सेम है. अगर आप लोग नहीं जान रहे तो ठीक है. Now just divide this alkyne. Both of these carbon atoms are same. So you can add OH on any of the carbon, and you can add what hydrogen on any of the carbon. So this will be CH3, C, OH. This carbon atom gets a hydrogen, and then CH3 as it is. Then again, this is going to be a double bond. It attacks like this. This hydrogen gives the water molecule like this, and you have CH3, C double bond O, carbon with 2 hydrogens and a CH3. All right, one more example. Again, both of these carbon atoms are different. Write this down quickly. Right, next. By ozone analysis of alkenes. This is B part on hydrocarbons. No. Please see the reaction, how it happens. You should have alkene. Now, alkene has a C double bond carbon. Now, both of these carbons can be connected to any two groups like this. Now, first of all, I am going to add O3 here. Now, addition of O3 does an insertion reaction and both of these carbon atoms break. And you get carbon, whatever bonds, whatever groups were attached to carbon as it is, those are attached. And then you have oxygen. Then again, the another carbon. I should not make this very large. Wait a second, guys. Like this. Then in the presence of zinc and water, cleavage happens like this. Now this carbon atom, whatever bond was attached to that carbon atom is still there and it gets double bond O. Plus this carbon atom, whatever bond was attached to that carbon atom, it is still there and it gets double bond O. This structure is known as ozonide. Please line. Treatment of alkene with ozone gives ozonide. On further reaction with zinc H2O, it gives 2 carbonyl carbons. Carbon किस पे गलत नहीं है हमने? Two carbonyl compounds लिख लीजिए, not carbons, 2 carbonyl compounds. I'm showing you guys one reaction with alkene. CH3, CH double bond, CH2. Okay, so please see here. Now, this carbon atom has two groups. आपको इस तरह से देखना है इसको. Carbon atom with CH3, carbon atom with hydrogen. Doubly bonded to carbon atom with both of these are hydrogen. ठीक है, आपको इस तरह से देखना है. अगर आपको कुछ भी मिल जाए, whatever alkenes you get, you try to find what are the two groups attached to one carbon and what are the other two groups attached to another carbon. Now, when you have added O3, you're going to get carbon, oxygen, carbon, oxygen, oxygen, and attached to carbon. Now, this is going to have CH3. This is going to have hydrogen, and both of these are having, both the groups in this carbon is hydrogen. Then in the presence of H2O and zinc, you get this breaks up and this breaks up. So here you are going to get CH3 connected to carbon, which is having a double bond O and hydrogen, plus C double bond O and two hydrogens like this. Okay, Josefa. Now, basically what you have to do is you just have to break this double bond. Please see this very carefully. You just need to break this double bond. ठीक है, तो डबल बॉन्ड ब्रेक करके ना, डबल बॉन्ड मतलब रखिएगा लेकिन ऑक्सीजन के साथ. This will get double bond oxygen. This will also get double bond oxygen. O3 in the presence of zinc and H2O. Then what is the product? CH3, C double bond O, a hydrogen, plus oxygen double bond carbon and then hydrogen. ठीक है? So very easy reaction. Products के मामले में you can write the product very easily. Just break the double bond and both carbon gets double bond O, double bond O. Can you write some reactions? Zinc H2O. Now this third one I am going to do. Give me the answer for the first two. Wait 2 more minutes. Then send whatever you have done. Except the third one. Third one, if you want, you can try. Otherwise, I will give the answer. Okay. थर्ड में एक एडिशन इस तरह से कर लीजिए आप CS3 यहाँ पे Yes, Samaya, whatever you have written, that is correct. Very good. First of all, break this one. So you'll write 1, 2, 3 carbon atoms here, then a double bond O. Now this is going to be obviously aldehyde because the carbonyl carbon is at the last carbon. So you can add a hydrogen here also. Okay. There is already a hydrogen here if you see. Plus this is going to be carbon, double bond, and 2 hydrogens like this. What about this one? Again, break the bond like this, give an oxygen here, give oxygen here. So you are going to get double bond O plus this is 2 carbon atoms. So it is going to have a double bond O. Now this carbon atom is going to have a hydrogen and a CS3. Okay, यहाँ पे देखिए hydrogen होगा पहले से. Now let us look at this one. One oxygen here, the other oxygen here. So you have 1, 2, 3 carbon atoms. The second carbon is having double bond O, and here also 1, 2, 3 carbon atoms. Second carbon is having double bond O. Now what about this one? You break the bond here. So you have 1, 2, 3, 4, 5, and 6. Now 1 and 6 bond has been broken. So this complete bond has been broken. Now I have a carbon chain of 6 like this. 1, 2, 3, 4, 5, 6. Now the first carbon atom, it is also having a CS3 group. Okay. Now this first carbon atom is going to get double bond O, and this sixth carbon atom is going to get double bond O like this. And it also has a hydrogen here, sixth one. यहाँ पे क्या है? Carbon के पास hydrogen. So if you have a cyclic compound, it is going to give you one molecule, but that molecule is going to have two carbonyl carbon for a cyclic one. Please write the answers. हाइड्रोजन इज नॉट नेसेसरी, बट अगर आपने हाइड्रोजन डाला तो जो आंसर चेक कर रहा है ही विल बी वेरी हैप्पी. ओके, आप जितना आसानी कर देना जो आंसर चेक कर रहा है उतना ज्यादा अच्छा है. सो ट्राई टू ऐड हाइड्रोजन. थिंक फ्रॉम द आप अपने पर्सपेक्टिव से मत देखा कीजिए चीजों को कि हमको कम से कम लिखना पड़े. यू राइट द आंसर फ्रॉम द पर्सपेक्टिव ऑफ द वन हु इज गोइंग टू चेक. ठीक है, तो आप खुद ही सोचिए आपको ये ज्यादा एल्डिहाइड की तरह लग रहा है या ये ज्यादा एल्डिहाइड की तरह लग रहा है. ओके, इन देयर मार्क स्कीम दे विल बी राइटिंग द एल्डिहाइड स्ट्रक्चर. तो जितनी आसानी से टीचर को लग जाए पता उतना ज्यादा अच्छा है. बट टू आंसर योर क्वेश्चन इट इज नॉट नेसेसरी. राइटिंग के मामले में, आंसर के प्रेजेंटेशन के मामले में, जब भी आपके पास सवाल आए तो थिंक अबाउट द पर्सन हु इज गोइंग टू चेक द पेपर. ठीक है, तो वो भी इंसान है, वो ऐसा वो रोबोट नहीं है कि वो सिर्फ सही और गलत देखेगा. ठीक है, तो उसका भी मूड सही रहेगा, मूड खराब रहेगा, बहुत सारी चीजें होती है. उसके पर्सपेक्टिव से आप लोग आंसर लिखिए जितना अच्छे से लिख सकते हैं. कीपिंग इन माइंड द टाइम. ऐसा नहीं कि सिर्फ एक सवाल को अच्छे से लिखने में बाकी सवाल में आपने आग लगा दी. ठीक है, एक कहावत है, महल्ला बचाते बचाते शहर जला दिया, तो वो मत कीजिएगा. एक सवाल की वजह से पूरा पेपर मत खराब कीजिएगा. ऑप्टिमाइज थिंग्स, ऑप्टिमाइज. चलिए, moving on to the next reaction. Now all the reactions that can give you both aldehyde and ketone, that is done. Right, next method of preparation of aldehydes only. This is your B part. Method of preparation of aldehydes only. Now in this, write number one reaction. Now this is the name reaction, Rosenmund reduction. Now अब यहाँ से आपके पास जो reagents है, that is going to be very important because all of these are name reactions और बहुत आसानी से आ जाते हैं. Please write. Acid chlorides are converted to aldehydes. Acid chlorides are converted to aldehydes by catalytic hydrogenation. In the presence of palladium over barium sulfate. So we have R, C double bond OCl. What is my reagent? Hydrogenation. Hydrogenation means H2 and PbBaSO4. The chlorine will be replaced by hydrogen. Two carbons and hydrogen. Even this can make benzaldehyde. अच्छा, also परसों आप लोग का फ्राइडे को सॉल्यूशन चैप्टर का टेस्ट है, प्रिपेयर करके अच्छे से दे दीजिए टेस्ट, ठीक है। एक बार चैप्टर प्रिपेयर हो जाएगा, फिर उसके बाद आपको बस मॉक टेस्ट के टाइम में सॉल्यूशन रिवाइज करना पड़ेगा। कम से कम एक बार तो आपका अच्छे से कंप्लीट रहे कोई चैप्टर। So start revising all those chapters from now on only. I hope you have got the syllabus for other subjects also. Right, next, Stephen reduction. Now please write for this. When alkyl nitrides are reduced with tannous chloride, and hydrochloric acid, tannous chloride and hydrochloric acid in ether. It gives andamine and on further reduction and on further hydrolysis, and on further hydrolysis, it gives aldehyde. So we have R, C triple bond N. And if I am going to do a reaction with SnCl2 with HCl, this is going to give me R, CH, double bond NH. Okay, so what has happened? On both carbon and nitrogen, we have added one hydrogen, and triple bond has been converted to double bond. Then on the addition of H3O plus, I am going to get R, CHO. See, here the water adds onto the CH like this, and you get NH3. Okay, so oxygen is taken by the carbon and the 2 hydrogen is taken by the nitrogen. So you get NH3 and then you get what oxygen of water molecule on the CH double bond. Now I hope you have done. Now in today's class we have seen many reactions. We have seen reactions of 1 degree alcohol and 2 degree alcohol. With PCC, it gives what? Aldehyde. 2 degree alcohol with reagents such as PCC, CrO3, all of these is going to give you ketone. Just don't heat it. Then 3 degree alcohol. What does it give? No, we have not done 3 degree alcohol. Then also 1 degree alcohol with copper and heat, it gives aldehyde. 2 degree alcohol with copper and heat, it gives ketone. 3 degree alcohol with copper and heat, it gives alkene. Now, another set of reaction that we have learned, this is from alcohols. Then we learned about hydrocarbons. In hydrocarbons, we started with alkyne. So if you have alkyne such as R, C triple bond, Cr, then first of all, then what is going to happen? One of the carbon atoms is going to get C double bond O and the other atom is going to get CH2R. Okay, so I'm going 2 steps. I'm just adding what? I'm adding H plus in the presence of H2SO4 and HgSO4. Then you have alkene. If you have R, C, some other R, double bond C, R dash and R double dash, so R triple dash. So in this case, O3 in the first step and zinc H2O in the second step. Both of these bonds break and you get carbon double bond O, whatever groups attached here, oxygen and carbon double bond, and whatever groups are attached there as it is there. Then we saw acid chloride. That means if you have RCOCl and you do hydrogenation in the presence of PDBSO4, this is Rosenman reduction, it is going to give you aldehyde. Then we saw Stephen reaction in which RCN, you first do reaction with SnCl2 and HCl. Secondly, you are going to add H3O plus and you will change this RCN to RCHO. So you have to remember these reagents, these are very important, okay? So we have done plenty of reactions today. Try to rewrite all the reaction on your own, and then we will start with some more methods of preparation of aldehydes and then method of preparation of only ketones in the next class. Okay. Okay. Thank you guys. Also prepare for Friday's test. Okay. You are having 2 time slots.